Now, if you remember earlier, I said that crude oil is composed of alkanes, and here we are talking about an ethene. So, what's the link? Well, one of the industrial uses of hydrocarbons is to turn it into ethene as a precursor for other industrial processes, and we need to know about that. So, there's a process where you can turn alkanes into alkenes, and it's a very important process, one that you need to learn about. Alright, so that process is known as cracking, and yeah, it's the first chemical process in this section that you'll need to know about. So, of course, you need to know about fractional distillation. That's a physical process. This is a chemical reaction. Right. So when we crack petroleum, what we're doing is we're converting an alkane to some mix that has an alkene in it. It's not always just an alkene, but the idea is to get alkenes. And in the HSC, it's important that you know about the ones that yield ethene, because ethene or ethylene is an important chemical industrially. So I'll give you one example of this. It's cracking octane. Octane is C8H18. Now, when you apply lots and lots of heat, 500 degrees Celsius, and the right catalyst, which is I believe it's called zirconium aluminium matrix catalyst. So heat and a catalyst is what's necessary. Basically, what happens is you can get into this long spine of carbons, etc., and break it up. And when you break it up, there's the potential there, because now they've got extra bonds for the carbons to bond to each other, rather than to be all bonded to hydrogen. So we can see logically that you've got a whole lot of carbons, and they've got hydrogens connected to them. When you break these bonds, when you break some of these bonds between carbons, that's going to leave this molecule with a free connector. It's going to leave this one with a connector. So it's going to have the potential to form new bonds. And in catalytic cracking, when that occurs, we can create ethenes by having this bond come on here. Ethenes, alkenes, although ethene is definitely one of them, and form an alkene. So we start with octane, which is C8H18, and then with heat and a catalyst, it goes to 3C2H4, which is ethene, and a single ethane, that's C2H6. That's a good one to know in case you're asked to provide an example. And yeah, and importantly, it yields ethene. 3 of these ethene molecules. You'll notice that the equations balance. 3C2H4 plus a C2H6 totals up to C8H18. So nothing's added in, it's just a single molecule is cracked up into some of its component parts, or into component parts of hydrocarbons. But because of the nature of breaking that spine of the hydrocarbon, you're going to have extra bonds. Some of those end up double bonding onto carbon, and that's exactly what we wanted, because we wanted to create that ethene molecule. Okay, so we've done fractional distillation and cracking. petroleum. Now we're going to move on to addition reactions and substitution reactions. So these are the first reactions you need to know that involve addition reactions are going to involve an alkene, the idea of an addition reaction, and we'll use ethene as an example because it's a really good one, and it's involved. Ethene's involved in heaps of this kind of stuff. In an addition reaction, a molecule with the double carbon bond, an alkene, is reacted with something that breaks this bond. Now, when you break one double bond, that means that there are now two free bonds on the molecule because this carbon can join to an extra one, and this carbon can join to an extra one. So this becomes just a single bond, and then so this is addition. And yeah, the important thing is that basically this molecule adds itself in. So we add a molecule into this one, and we end up with just one product. So there's a few different addition reactions, but they've all got very similar kind of patterns to them. You can add hydrogen gas to an alkene in addition reaction. So I'll give you the ethene version of that. So this one plus H2, which is HH, that goes to, what happens here is this breaks. So these already have hydrogens. I'll draw them in now. So this breaks. This now has two free bonds. One on this carbon, one on this carbon. There's exactly two hydrogens here, and they each go to one of those. And so we get a C, and each are now joined to three H's, and that's ethane. So the addition reaction here has yielded ethane from ethene. It doesn't end there. There are lots of other addition reactions as well. For instance, so we've just added H2, but we can also add a haloalkane. We can also add a halogen gas like Cl2, and in each of those cases, so the haloalkane, it's the same thing. The two molecules just add in. So it's like this one's going to be like alkane, but instead of having an H and then another H adding in here, we've got an H, so that's added in here, that's good, and then a Br. So this addition reaction of ethene plus HBr is going to yield bromoethane. And if you added Cl2, same thing's going to happen. I'll just take you through it again in case you're not clear what's going on. So we start out with the ethene, this double bond, right, that turns into a single bond. The double bond's broken. That leaves, sorry, these weren't here to begin with. The double bond is broken. That creates the potential for extra bonds. The Cl2 comes in, joins in. So we end up with just one molecule as a result. In this case, if we add a halogen gas, we end up with a dichloro or a dihaloethane. In this case, it's dichloroethane. Great, so that's addition. It is what it sounds like. You're adding a molecule in. The important thing to note is it only applies to not just ethenes, but alkenes rather. So it's an alkene plus some molecule, typically a gas with two molecules in it, H2 or HBr, and then it goes to some kind of alkane-based. So it can either be an alkane or a haloalkane, an alkane-based molecule. Awesome. Alright, the other kind of reaction you need to know about that goes on with hydrocarbons is the substitution reaction. Now, what's really important to remember here is the substitution reaction starts with a different molecule. So we're still going to be trying to add the same sorts of molecules. We might be trying to add something like HBr or Br2, L2, these kind of molecules. But instead we're going to start with an alkane. So that's already saturated with hydrogen. Now it doesn't have that reactive double bond. It's not as reactive. So what that means is that it's not going to react as readily, and it's not going to be able to just absorb this molecule into it. It's actually got to substitute out one of its hydrogens. It's got to swap that out in order to join. So it's not going to happen as readily. It's going to proceed more slowly, and it needs a special condition, which is UV light. So the substitution reaction involves an alkane plus some kind of halogen based gas and or solution, and that's going to create your haloalkane. So it's got a one similar product to the addition reaction, but it's also going to have a gas as well, because this this halogen-based thing did not just get absorbed straight into the alkane. It's still, things have been swapped out, so we're going to have more than one product. Let's see how that works. Some free space. Right. So let's say we start with, for the sake of sticking with the theme, ethane. That could happen to any alkane. And we add HBr. Now we're going to need UV light, and it's only going to proceed quite slowly under normal conditions. Alright, what are we going to get? Well, when we add the HBr, we're just going to substitute out one of the bonds. So we're going to end up with bromoethane plus, now this H is going to switch for this Br, so we're going to end up H2 gas. Alright, so that's the addition reaction. Or rather the substitution reaction.